In the last lesson, we were looking at CHOPS and how we can use textures and various pipeline manipulators to allow us to control images inside Touchdesigner. Today we're going to move on and look at the close partner of CHOPS, CHOPS. Now, CHOPS stand for channel operators, but the better way to look at them is just any sort of visual or hand-coded. The better way to look at them is any sort of data that needs to be manipulated inside Touchdesigner that isn't in a pure text format, such as a text or a table, like you would get in conventional coding. A CHOP is a way for us to take data, manipulate it, in some cases create it, and use those values to then drive or derive different sort of top animations. So when we look at the default Touchdesigner template, we can see that it's a standard top pipeline. It does get applied to a 3D shape, but we don't need to worry about that for now. So we can see that we have a top pipeline that is a movie file in, going to something called a displace, and then to an out. This is something that we can recognize from the last tutorial. What we don't understand is this chop noise. And when we call a chop a channel operator, it's because it can have both a value and a length. In this case, what we're seeing here is a noise that is 120 channels long. So it's basically has a value for 2 seconds worth of frames. Obviously, we're running in real time at 60 frames per second, which means that 60 frames in 1 second makes 120 frames in 2. So we have 120 frames or 2 seconds worth of previous data visualized here inside this what we call a noise chop. And we can even see that there's an expression in here on the translate for the noise's X value, so this up and down value, and we can even see here there's an expression in this operator's transformation that allows us to manipulate, that uses time itself to drive its randomization. In its channel, we can see that it ends at 2 with a sample rate of 60. Again, reiterating that idea that we have a single sample for every frame in a 2-second range. That can be a bit complicated to take in, so I'm going to delete everything and I'm going to make a really simple top pipeline. I'm going to make a circle. I'm going to add it to a transform, and that transform is going to go to a null. Very standard, and we know that we can use our transform top to move our circle within our space. But what happens if we wanted to do this with data without us having to interact with it? This is where CHOPS come in. But what happens if we wanted to be able to interact with our transform without having to come and select this node every time? This is where CHOPS come in. So the amount of operators can be very overwhelming for a first timer, and with due cause. Because there's so many here, because CHOPS deal with so much stuff. They deal with data, they deal with input and output, they specifically deal with audio and all of the audio controllers because audio is data over time. But the go-to for me is always going to be a constant. A constant is exactly what it says on the tin, in the same way that a constant top is a single color that we can set the value of. A constant chop is a constant number of values that we can either edit, control, or manipulate. So you can see that when I make my constant, it has a default of channel 1 with a value of 0 that I can change. And I can change this value to be anything I want. So a constant is literally a place that I can just hold a value. And its name can be anything. So in this case, I could put X trans. And then if I fill in the next channel name, it will instantly activate and give me access to not one, but two channels in here. Now, different to our noise, our constant is currently a single sample. So if I go to the constant channel tab, we can see that single sample is enabled, which means that this constant will only have one value for the single frame that we're on. If I was to disable that and give it a range, in this case let's do 0 to 1, it now means that my constant could trnically have 60 different values for every sample in our channel. So you can see here that I still have my X trans and my Y trans, but now they've turned into this bar that means in theory I could have 60 different values going left to right as I could up to down. We're never really going to use a constant as a multi-channel tool, so I'm going to re-enable single sample. I do want you to be able to though understand that constants, I do want you to be able to understand though that CHOPS have values that can either be single per frame or show multiple values across a range of samples. A good way to visualize this is if we introduce a trail chop, and in the trail chop I'm going to set its window length to 1, which means that we now have both of our channels visualized with a value of 60 samples. So if I was to change the value of one of these, every time, so I've set my window length to 1 and I'm going to set my capture to be when input cooks. And this means that every time that the input value changes, for example trans X, it means that this timeline will update, which means that I can save the historical values over the past second inside my trail. If I leave it on time slice, it means that every frame that passes in time, this trail is going to update with the latest value from our constant. So now if I change it, I can make the same wave, but we can see that time keeps progressing inside of our trail. So this is a really good way to update and track historical values if you're unsure of what's coming out of a constant, if you're unsure of what's coming out of a chop, but it also means that we can get a null reading because it's just been so long since our value changed. I'm going to leave my trail connected there for now. There are various reasons that we'll use one, but we're never going to encounter it while we're inside top and chop manipulation. When we reach 3D and we start looking at multi-instance, using multiple instances of the same geometry, then we can affect channels as well as just samples. Then we can affect samples as well as channels. So I'll leave my trail up there for now, just so we can see what's happening. And I'll switch it back to only when the input cooks. When we look at a standard chop panel, it has most of the same manipulators that we're used to when we were dealing with our tops. For example, there's nulls. There's nulls. There is something called a transform, but we probably don't want to be messing with this. But the transform doesn't work in the same way that we'd expect it to. But this transform specifically relates to trying to transform data from one space to another, and we just aren't operating like that. There are operators like transform, but when we use chop operators, it's more just a case of trial and error. Across all operators, tops, chops, sops, mats, stats, etc., there are a number of consistents. Things like there's always a null. There's always something like a constant, a way to make an ever-emitting or never-changing piece of data. In here, we have two values, and in our top, we have a circle. But there's always different ways to manipulate data depending on the type of operator style you're in. One of the most common ones inside constants one of the most common ones inside CHOPS is the use of something like a math node. So a math node allows us to take a value in, apply something to it, and pass out values depending on what we select. So one of the most common ones is that we can use a to and from range. So let's say that my input chop goes from 0 to 1, but I want a much bigger output. So instead of my range going from 0 to 1, I'm going to say I want my range to go from 0 to 100. So now, a value from here that goes from 0 to 1 inside this math will be transformed in something from 0 to 100. So we can see that it still keeps the same scale, but it now allows us to adjust values depending on their input. And this is very powerful because the ranging tool inside Touchdesigner is also adaptive. So even though I've set it to be from 1 to 0, or from 0 to 1 and 0 to 100, it now can understand values of 147 should equal 14,709 inside the math. There's also different operators we can do to actually deal with. There's also standard programmatic operators we can do. Let's say I have an x and a y of this. Instead of passing them through in my for range, I can actually combine these channels, so I could add the two together. So it will apply my to from range, it will then combine them together. So in this, it's added my two channels together, in this case 0.28 and 0.68, which equals 0.96. It's then adapted it through my from range and given me the output. Given the way that my input works, it means I have a maximum in range of 2, which means I could adjust my to range to be from 0 to 100 still. So it means that a value of 0.5 each, I have an overall value of 50. But this can get quite confusing quite quickly for someone that doesn't know what they're looking for inside Touchdesigner. So I'm going to return my combined channels to off, and I'm going to remove my range. And all I need to know is that we have options to add multiple channels from a constant that has 2 in this case. We can also add multiple chops together. So combine channels, combine chops. And it now means that I can take same named channels, xtrans and xtrans, and add them together to get a constant value. And already we can see that with very little work, we've started to be able to create, manipulate, and control various types of data inside Touchdesigner. Now, before I go too deep into that, I have set up a parameter for my X translation and my Y translation because I want to control this factor of my circle. We can use, inside Touchdesigner, it links Python throughout. Nearly all nodes are Python enabled by default in some way or another. The noise that we looked at on the very first example had a piece of Python code inside of it running the frame timer. To do that on my own, down the bottom right hand corner, when we first talked about nodes, we talked about being able to activate a viewer. If I activate a viewer, you can see I can now pick and apparently do stuff with the values inside of my null. If I go to my transform and try and pick and drag my value into my top transform, you can see that it's a valid way to use that value. I get the options to export the chop, export a chop reference, or just take the current value that it's set at. So by clicking current chop value, I would set my transform parameter to be what is 0.5. If I click chop export, it means that anytime that my chop changes, the transform will recook. But if I do a chop reference, it means that it's going to programmatically fill out a piece of Python code for us inside Touchdesigner and link to this chop. And this is indicated by the grey dotted line. So whereas green to green and purple to purple are solid lines we can interact with, data connections are grey dotted lines that show us the direction of travel indicated by the arrow. So I'm now going to hook up my Y translation as well, and we can see with a value of 0.5 and 0.5 is in the top right corner. If I set both of these back to 0, it means that my circle sits in the dead center. So already I can tell there's an issue with my range, because I want to be able to go from the left hand side to the right hand side, or the bottom to the top. So instead of going from 0 to 1, like the range of my constant, I want to go from -0.5 to 0.5, like top space. So in my range, instead of 0 to 1, I'm going to say -0.5 to 0.5. And now if I move it up, we can see that I'm able to go from top to bottom, left to right, within the limits of the top. And already we're starting to control how we can move our shape. But this is still a little bit too much manual work for me, so I want to look at a chop that's going to allow me to create data as well as manipulate it. And a good starting point for this is going to be an LFO, a low frequency oscillator. And all it does, and what this does, is it generates a wave of real-time data using a number of common maths functions. By default, it's set to a sine wave. Now if I connect this to my trail, we'll see we get a constant, smooth, mathematical sine wave. So that goes from -1 to 1 over our length of time. Frequency here being 1, which means that we want it to do a single wave in 160 sample section. So if I change this down to 0.5, it now means that I want it to do a single wave in 1 divided by 60 . It now means I want it to do a full wave in 60, or frames per second, divided by the value of samples, which means that 60 divided by 0.5 means 120. So it's now going to take 120 frames, or 2 seconds, to complete a full wave. In the same way that if I do 60 divided by 2, it means that it'll now do 2 waves every second, or a full wave every 30 frames. So now I can make data. Let's do something with it. So in my types, there's lots of movements we can do. There are sine waves, a Gaussian wave, which is, it has a tighter top with a shallower bottom. A triangle, which is literal up and down on a steady ramp. A ramp that goes from 0 to 1 rather than going below, rather than going into negatives. A square, which is a pulse of -1 to 1, and then an actual pulse that gives us every 60th beat we get an on and off pulse. So it's very hard to see inside our chop, but with our trail we can really easily visualize it pulsing. Okay, so I'm going to set this to a ramp. So I know I have a value that goes from 0 to 1. And inside my channel, I want this to have 2 channels the same way my constant did. Now by default, I can't as easily add a second channel as I did down here. But if I change the name to be xtrans, and then put a space, and then type ytrans, it's going to give me 2 LFO ramps with 2 different names. And if I plug these into my math, and delete the original, it means that my link and reference is still going to be the same, and the animation, and we can start to animate our content. Now the reason this works straight away is because my channel names were the same. If I was to make these the default channel 1 and channel 2, we can see that our transform has a blaring error on it, and that's because it says that it can't find null 2 with the channel of xtrans anymore. Because if we look at null 2, it has 2 channels, one is chan 1 and one is chan 2. So you could technically relink this by either changing the name, activating your panel and dragging it over, or as we did, we can simply just make the names of our input channel the correct ones. Sometimes it's hard to forget where you can and can't rename channels, so thankfully there's the super helpful rename chop that allows me to take whatever I have coming in and change it to be the value that I want. In this case, I'm going to do a wildcard, which is a star that says take all the input channels and turn them into whatever I type here. Again, separating channel names by spaces. So now I take an LFO with two channels called Chan 1 and Chan 2, rename them to Trans X and Trans Y. That goes into our mask that changes our range. And then in here, I'm going to relink it so it now says Trans 1. So already I now have two different operator types causing an animated effect inside my environment. So now I have two different types of operator interacting and speaking to each other to create a more dynamic real-time experience. In this case, we're making an animation. But I want to make it a bit more exciting. I want to make it look like my circle is completely flowing on and off my screen. So I'm going to adapt my range a little to say from -1 to 1. So it looks like, and because my circle has a range of 0.4, it means that it will travel completely on, it'll go from completely off the screen to onto the screen to off the screen again. So we get this ever-flowing effect. Like last time, when we were working purely with tops, I want to explore the idea of how far we can push this to create a linked up experience. So I'm going to quickly save my project. And what I'm going to do is I've, like last time, got a few prepared assets that I'm going to bring in. And rather than these being static images, they are now animated GIFs that we want to try and recreate using what we know with our knowledge of tops and chops. So what I'm going to do is we're going to do this one together in situ, and then I'm going to give you another one that I want you to try that you can do on your own. So for this, let's have a look at it in general. I'm going to click on the movie file in that I just dragged in, and I'm going to pause it and reload it. So we can see its default setting here, and let's look at what our basic top setting needs to be, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. And I know how to make a square, so I'm going to make a top rectangle. And I'm going to, rather than make the small one, I'm going to focus on making the big one. So I'm going to increase my resolution to about 1000, so we have a nice detailed square. And I'm going to make it size 1 by 1. I'm then going to have a look at what we need to make color-wise, which is going to be a nice dark blue. So I'm going to make a nice dark blue. I'm then going to introduce a multiply, like we did last time. So now I have my color. And on my multiply, to make sure that I maintain my resolution, I'm going to make sure my fixed layer is the higher of the two. In this case, input 1 is my 1000 by 1000 square. So I'm going to select input, input 1. And that now means that my size is 1000 by 1000. And to get this little tab up, I'm just pushing middle mouse on any tab. It's the same as the I button up here. And it just means that I can get information down here. So it's a 1000 by 1000 texture that is 16 by 16 or 1 by 1 aspect ratio that has 8-bit color inside of it. Also tells you a bunch of information about actually how it's used in memory, but we don't need to worry about that at this stage. Okay, so I've made one square that is big and purpley. I now want to add a transform, and I'm going to add this to a composite, just like we learned last time. And I'm going to set my composite to over. With that done, I want to introduce a number of these squares, and I think I said there was 9. So I'm going to select these 3 elements and copy and paste them. What we can see is that our multiply and our transform all stay consistent. But now I can change the color of my transform slightly. I'm going to come in here and I'm going to increase our green ever so slightly in each square so that we make our color brighter. So this was 3.5. I'm then going to copy and paste it again. Copy and paste it again. So that's me on 7, 8, and 9. And it's not perfect, but the colors are there enough. I'm then going to select all of my transforms on the right hand side and drag and drop one with them all selected, and it will automatically connect all of my transforms. I'm going to have a look at my operator, and what I want to do is attach this to a null, and I want to show that null in the background. So now I have a bunch of squares that are all the same size, but my lightest panel should be on top. So I'm going to change my operator type to be under, because I don't want to have to rewire all of these the other way, but I already know that they're actually in the right order. Just rather than being over, I need to get the bottom panel first. And now I can make a number of changes to change the scale of each of these squares so that I can get this pattern. So I'm going to come in, scale this one down, so about 1 or 1.5 looks fine. And then the next one, I'm going to, again, scale down. So about a 10 increase every time seems to work. So this one will be 0.45, 5.5, 6.5, 7.5, 8.5, and then let's do 9.5. Okay, and then I'm just going to quickly change the color on the last few of these because they get pretty close. So I'm going to set this to be all the way purple. This one I'm going to make a little more blue. And now we can see we have the step. And the last thing we probably want to do is add another one just so we have a blank background. So I'm going to copy and paste the top square, reset it back to a scale of 1, and give it a constant background color just so we can see what we're dealing with in the background here. Plug it in. And then I need 11 to be all the way at the top, because remember we're doing under rather than over. So now I have a constant background. It's not perfect. I'm not striving for perfection. I'm just trying to recreate the effect here. So now we've got that, we can consider what is actually happening inside of the animation. So if I play this again, we can see that all of our squares are rotating on a slightly different axis. So in my head already, using what we've just learned, I'm thinking that I have an LFO that goes from 0 to 1, that I then add to a range of 0 to 360, so I can create the effect of rotating a circle 360 degrees. And then I'm thinking that I'm going to have to add each of those I'm either going to need to have an LFO per square because they're all rotating at different rates, or I'm just going to have to add a different range to each math. So if I have one LFO driving them all, it means I can keep them all in sync. And if I adjust the ranges, so let's say the middle circle does so however many rotations this middle square does against the outside square, we can then start to work out how to alter our math. So I'm going to make my LFO, and I'm going to make it a ramp on standard 0 to 1, and I'll keep it on the same frequency. So it takes a full second to go from 0 to 1. Then I'm going to add it to a math and go from a range of 0 to 1 to 0 to 360. I'm then going to go to a null, and I want to change the rename here to be rename. I'm going to change this to be square 1, and I'm going to plug square 1 into the my purple background, but the one after that, so my 0.95 rotation here. I'm going to export my reference. So two things is it goes way too fast and it's going the wrong way. So in my LFO, I'm going to slow it down to about half the speed. And then I'm going to invert the range. So instead of going from 0 to 360, I'm going to go from 0 to negative 360. Okay, that might still be a bit fast, but we can come back and change it later. So now I have a null that says square 1. I have a math that changes our initial range from 0 to 1 to 0 to negative 360, and I've got one rename. I'm going to I'm going to add a second math by typing it, and take a chain off my main math. And in here, what I want to do is I'm just going to multiply the result. And what I'm going to do is in here, instead of going from 0 to 1, if I change its to range to be from 0 to 1 to 0 to 2, so what I'm going to do is I'm going to add an LFO, and I'm going to change that LFO to be a ramp. So our ramp, on our ramp mode, we know it goes from 0 to 1 over and over and over again. Now what I want to do is I want to look at this middle square as my starting point, and I'm going to presume that all the other squares are calculated from it. So looking at this, I'm going to say that my frequency for that square is about 0.1, if not slower, which means that it takes about a minute for it to do a full rotation. So that I work in the right denomination, if we look at the transform for an object, we need to rotate it by 360 degrees naturally to turn a full circle. So I'm going to go from my LFO into a math, and I'm going to change my range to be from 0 to 1 to 0 to 360. I then want to know which square I'm using, so I'm going to add a rename, and I'm going to say square 1. And finally I'm going to add that to a null, activate it, and connect it to my transform at the very bottom here. So there we go, we can see that we have one LFO rotating our middle square. The first thing is that it might be slightly too quick, but I'm not worried about that right now. And the second is that it's rotating the wrong way. So the one thing I can do for that is I'm going to add a multiply, instead of multiply 1 in my multiply add tab, I'm going to change that to -1. And that means it's going to negate whatever value comes in by timesing it by -1, and then still adopt the same range parameters of 0 to 1, 0 to 360. That means that we now get our square turning the right way. What I'm going to do is I'm going to add a second rename and call one square 2. And then I'm going to introduce a chop called a merge. And as per the name, it works like a composite for tops and allows us to combine multiple chop channels together. In this case, if I now plug that into my null, it means that I have my rename for square 1 and square 2, and my null is still correctly linked to my bottom square. If I was to link square 2, if I can get it to activate, if I was to activate square 2 to my second squares transform, what we should see is two squares that spin in perfect order. But what we want to happen is we want to see how we can manipulate the value of square 2 so that it slows the rotation of the other square. And if we look at what's happening, it means that this outer square is rotating at almost twice the rate of our middle square. So if we count that as a default, this square is currently at 45, this is now at 90. When this square is at 90, our outside square is at 180. So what I'm going to do is I'm going to insert a math to see if I can recreate that. So we could effectively say that our outside square is rotating at twice the rate of our inside square. So in theory, if we multiply this by 2, so if I multiply this by 2, what we can see is we get the effect of our square rotating at twice the rate of our inner square, but it maintains the perfect 0 to 360 degree, or now in this case from 0 to negative 720 correctly. I'm going to explore this idea for all of my cubes because I think that they all operate to the same idea, that they're just a multiplication of the one before it. So I'm going to copy and paste again, and this time instead of square 2, I'm going to say square 3, connect it to my merge, have a look at my third square in the row, make sure I connect this to rotate, update my math, so instead of 2 it's now 3, and now I can see I'm starting to get the effect that we get over here. I'm going to quickly I'm not going to speak, and I'm going to time-lapse this video while I duplicate these parameters for the rest. Okay, and there we go. So now I've connected all 9, or all 10 I think squares I have now, and all the way up to the outer square is turning 10 times as fast as the middle square. My whole rotation is probably a bit quick, but thankfully I can reduce the frequency of my LFO to slow down the animation to be somewhat more in line with our GIF, without having to change any of the programmatic links. And we now get this amazing effect of this aligning and unaligning square inside of our viewer panel. Now, I'm a stickler for organization, and I hate this being out of order, because the merge simply just affects them on the way that they come in. What we can add is, thankfully there's almost a chop for everything, there is a sort chop that we can add. And we can sort the method by either the values that are coming in or by the names of our channels. I'm a stickler for organization, and I really dislike this pattern looking like it's out of sort. So what we can do is, obviously there's a chop for almost everything. We can add a reorder chop that allows you to reorder the channels inside a chop, rather than something like a SOP that actually converts, rather than the sort, that actually converts the samples rather than the channels. So channels being up and down, samples being left to right. Oh, so they're not that. So if I right click, insert a reorder, not that, if I right click and insert a reorder, I can tell it to sort it by base name, and it now means it will go from 1 all the way up to 10. We will get this weird effect of where it looks like some of our channels are more scaled than other, but that's simply because Touchdesigner is going to try and automatically sample down our viewer so that we can see the right amount of data at the right time. The purples showing us a different input than the pinks, knowing that these two are in scale, whereas everything else is in a uniform scale with itself. It's a way for us to visually know what is and isn't operating inside the Touchdesigner window in the same scaled parameters. So with that done, now we have created a super dynamic real-time animation inside Touchdesigner using both CHOPS and TOPS. There's only so much we can teach about both of these things without having to just continually develop with both of them until we get comfortable with what we need to add and where. Developing pipelines and understanding how to manipulate data in the way we need it to, as we did here with a single LFO driving 10 different circle animations, is really important. So as my task for this video, what I would do, I have another animation that I want you to recreate, and that's this circle wobble here. So if I disable both my null and my input, what I want you to do is I want you to attempt to recreate this GIF, which is a similar style, but the animation requires much more complexity in what you implement. My clue would be, or my hint would be for this task, is that an LFO going that way and an LFO going that way, or an LFO going left and right and an LFO going up and down, that are offset to each other by half of their duration, will give you the effect of moving around a circle, as we see here. So I'm going to stop my recording and I'll pick it up after I've developed this, so please pause the video and give it a shot yourself.